Computer. All right, so welcome everyone to, I guess, week 3. We're going to be talking about chapter 2 tonight on summarizing data. So here's a quick look at our agenda. Actually, just like I said, we look at the 1-minute papers. It's kind of like a quick kind of word cloud that we created with some of your responses. Try to address some specific questions in a little bit. If you still have lingering questions, we can get to that, but got a lot to cover tonight, so I'm going to just get into it. Got 2 quick announcements for those who are working on homework 2 and may have encountered an issue. So evidently over the summer, the OI data package is no longer on CRAN, and everything's been moved to the Open Intro package. And as a result, as part of the migration of the data from the OI data to the Open Intro, they, I think, renamed some data sets to be, understandably a little bit more meaningful. And so I was using one, didn't catch it over the summer because I still had the OI data package, so it didn't fail for me. But I've taken it out. So got a couple of solutions for everyone who's having that trouble. If you've already started the homework, just do if you do Control F or Command F in RStudio, you can do a search and replace, and you can just search for heart TR and replace it with heart transplant. All the instances in the document, and things should just work. If you haven't started the homework, I updated the homework file on GitHub, so you can just go and download this file, and it'll have the updates in there. I also made a few minor updates to the Data 606 package, one of which to reflect this OI data issue, but I think there are a couple other little minor things. Because it's on GitHub, in order to update it, you really just reinstall, and it should reinstall on top of it. So that will happen from time to time. I'll make announcements as, sometimes I add new shiny apps or new little, utilities or functions. So just address that. We got 3 homework presentations tonight. So I forgot to enable screen sharing. So I have Lisa up first. If you want to share your screen, you should be able to do that now. Are you there, Lisa? I see your name. Oh, here's your screen.
Hi, can you hear me?
I can hear you. We can see your screen. So the floor is yours.
Okay, so I did problem 1.13, and it was actually looking at the relationship between air pollutants and preterm births in Southern California. They looked at the length of gestation data and air pollution exposure for 143,000 births between 1989 and 1993. So the first question was identify the population of interest, which the population is all births in Southern California, and the sample in this study is the 143,196 births between 1989 and 1994 in Southern California. The second part of the question is asking whether or not the results can be generalized to the population. And if the 143,000 births during that time period in Southern California are representative of all the births in Southern California, then the results can be generalized to all the births in Southern California. And then they ask if the study can be used to establish causal relationships. And because the study is observational, there's no treatment or experiment. So the results cannot establish causation, only association.
Is that it? It looks like you have a second slide. Oh, okay.
Oh, well, the second slide, I was just referencing the exercise 1.3, but
okay. Yeah, that's great. The only thing I would add is, like, when you're thinking about that first part of question B, just think about randomization, right? That's sort of the kind of key pieces if the sample is randomly selected, right? So often using that word random is helpful. I have Esteban up next.
Yes, sir. Let me share my screen.
Oh, Lisa, can you stop sharing? So there we go. Thanks. All right. All right. Can see your screen.
Okay. All right. So I did exercise 137. In this exercise, there was an experiment that took place where they use chia seeds and they tried to find a relationship with the weight loss. So they gathered together a group of 38 men and 38 women, and they randomly distributed them into two groups. One group, well, actually, maybe I should answer the question. The question asks first, what type of study is this? This is an experiment. What are the experimental and controlled treatments in this study? In this case, what they did is for those participants, they randomly put them into each group. And the first group, the experimental group, was given 25 grams of chia seeds twice a day, while the control group was given a placebo. The other question was, has blocking been used in this study? If so, what is the blocking variable? I did not see any other variable that was used in this experiment that would need to be blocked other than the experimental variable itself. Then he said, has blinding been used in this study? My answer is it's not certain if blinding was used because the exercise doesn't say if the subject knew which group they belong to or not. And it doesn't say if the researchers knew about the subjects, if they belong to a particular group or not. So I don't know. Apparently, there was no blinding use, unless it is assumed that they didn't know which group they belong to. So I wasn't sure how to answer that question. If I just make the assumption, or
I think your answer is fair. It's kind of interesting. I might have assumed that because there was a placebo, the placebo is often the thing that's used to kind of trick. So like in medical research, right, you give a sugar pill. So everybody's taking a pill and people don't know which one's the real pill and which one's just a sugar pill, or, but you are correct that the problem did not state that was, so assuming that from the placebo is not entirely accurate. So it's good to question that.
Right. Yeah, and the question was comment on whether or not we can make a causal statement and indicate whether or not we can generalize the conclusion to the population at large. So my answer is we could make a causal statement because this was an experiment which followed, for the most part, the experimental design principles, the controlling, randomization, and probably replication, but I'm not so sure about that because the group that they used seems to be kind of small. They only selected 30 men and 38 women, which may not be large enough to accurately estimate the effect of the explanatory variable. So I wasn't sure about that. And because of that, for the second part of the question, I say that this group may not be large enough or representative enough of the population. So therefore, we cannot generalize the conclusion to the population at large.
Yeah, this is great. I like your thinking on this, Espen, because as I mentioned last week, the statistical procedures we're going to learn this semester are the same. They're the procedures that we use for causality and that we use for observational studies is going to be the same. We're going to talk about differences, if we're talking about differences in groups or predictions, but that interpretation relies solely on the design of how the data was collected. And I like your thinking through this, and that's going to be critically important to have some nuance on these pieces as we go through. So thank you.
I was going to ask, weren't these blocked by sex? I mean,
Uh,
they split the men and women off first, and then they split them into two groups.
Yeah, I couldn't read the top fast enough. Oh yeah, you're right. So yeah, gender sex was definitely a blocking.
Yeah, I was thinking about that too myself, but I wasn't sure. I don't know if they did this in sequence, and that's why they mentioned the men first and then the women, or if they explicitly separated them first before they assigned them to the other group. So it was not very clear about that.
Well, no, because it says they recruited 38 men and randomly split them and then recruited 38 women. So I think they definitely blocked on sex here.
Okay, all right.
Yeah.
It was just my interpretation of,
Yeah.
yeah. If we look at it that way, then yeah, they did use blocking.
Mhm. All right, Mauricio, have you up next? And I think you need to stop sharing. Yeah, there we
Yeah.
go.
Right.
Well, let me, William, does random sampling apply to retrospective observation studies? So blocking and stratified random samples, help me out, Angela. I could think they're essentially the same thing. Yeah, I think they're the same thing because you're just taking some key variables and just doing the randomization within those groups. So I think they're the same, but retrospective observational study, and if there was randomization that occurred, you could find random. So economists or econometricians do this all the time, and they often look for what are often referred to as natural experiments. So sometimes from an observational study, you could find something that is akin to a randomization process. So there's a popular method now in the economics world called difference in differences, where some random event occur, usually because of nature, not because of a researcher's intervention. And if you look at the changes before and after that random event, you could, and you can reasonably reason that event caused, some kind of randomization to occur. I'm trying to think of an example. The example, one of the more controversial examples that comes to mind is a study that Stephen Levitt did, and he talks about in his book Freakonomics, where he was looking at the estimates of the impact of Roe v. Wade on crime in inner city. And so he looked at the differences in crime rates in cities across the times when they legalized abortion. And so, New York City legalized it, and then Chicago legalized it 6 months later. And so by looking at those trends, so the fact that New York legalized it before Chicago is arguably a randomized event, or the fact that somebody might get pregnant, 6 months before or after is more or less random, that there weren't, as far as we know, environmental or cult, societal impacts that would cause somebody to fall on either side of that line. Actually, another example where it's kind of an observational study, they also looked at the impact of magnet schools in Chicago. And what they did is looked at, students or families that applied to go to a magnet school, and because of random chance, because it was a lottery, so everybody could apply, right? And so the population of interest is all families that applied to a magnet school, and by the lottery process, some got in and some did not, right? And so they looked at the differences between those that went to the magnet school and those who just ended up going to the public school. In that instance, they found no statistical significant difference between those two groups. So in a way, that's kind of another natural experiment just by virtue. So, those are a few cases in observational studies, but the researcher didn't control that randomization. And sort of when we think about the gold standard randomized control trial, it's that control over the placement in those two groups that really gives the strength to that to the causal claim. Is that help William and Alec? Yes, no, maybe.
Yeah, that's great.
Yeah. So, yep. All right. So, Mauricio.
Yes, I'm doing question 143, the Stanford Open 30 question. And, here we have this table, which is a table of police stops in these counties in Arizona and Wisconsin. I imagine there's more states, but what we have here is a summary table. And we have several variables: county, state, driver's race. And then because this is a summary table, we have number of stops and percent of stop cars searched and drivers arrested as a derived variable. The raw data, which is not made available, what I would imagine is essentially a table which looks like this, but instead of numbers here for car search or drivers arrested, you have a yes or no. And the number of rows or records for this raw data is the sum of these numbers here. So what we have here is a summary table, but the raw data, again, wouldn't have these numbers. They would have just a yes or no, a categorical binary variable. And then this summary table is put together on the basis of statistics of that raw data. So let's keep that in mind. This is a summary table, not the actual data that was collected. Then the question is, of the variables collected, which are the types? And the variables collected are county, state, driver's race, car search, yes or no, driver arrested, yes or no. I'm referring to the raw data, not to the summary table. And the next slide asks what type of variables these are. And then we have, they're all categorical, non-ordinal. And it should be pretty obvious why they're categorical and non-ordinal. For example, Arizona is not better or worse, higher or lower than Wisconsin in any regard. It's the same for county, the driver's race. So these are the variables that were collected, 5. And again, the summary table that we're presented with here is these columns, percent stopped and number of stops, is a derived column based on the number of rows and the answers to cars searched and driver arrested in the raw data. And then we're asked which one is the response variable and which one is the explanatory variable. And the response variable in the explanatory variable, let's look at that first, is race. And then the response variable is the percent of cars searched and drivers on race. You see here the data is grouped by race. And that's it. Let me go back to this table in case anyone has any questions.
Great. No, that's great. Thanks.
I have a
Mauricio.
question.
I have
go
a
ahead.
question. Sorry, continue.
Go ahead.
Go ahead. Whoever else has a question, then I'll ask mine.
Yeah, go ahead.
My question is not really about the presentation. I really want to know where the assignment and the lab for last week was saved, because it seems like I did something differently.
I'm not sure what
This
you
is
are.
not a homework or assignment
Yeah.
problem.
So
I chose this at random.
Yeah. So if you go to and I think I covered this, and if I didn't cover it adequately, this is a good time to ask the question. So if you go to, so one of the course requirements is to do like a homework presentation, any odd question from the chapter of the week. So if you go here, there's actually a presentation sign up, and I see a lot of people already signed up throughout this, if there's a particular week, that's good. But so next week we'll get some people presenting on chapter 2 questions. if you're looking for a little bit of detail, it's under the participation section. So you just present, less than 5 minutes. Just think of this as the old school going to the chalkboard and working out a math problem. That's kind of what I'm kind of going for. So I have, a number of purposes here. One is start to get you some experience of presenting statistical problems, because you're, as a data scientist, are going to need to do that a lot. Trying to do it in a, smaller, safer space, I think is really good. And to be succinct, right? Short is the key here. So you just need to do one sometime during the semester. Does that answer the questions? Is that what the questions were, clarifying what the assignment was?
Yes, sir. Thank you.
Yeah, no problem. And then if you're interested, Stanford Open Policing Projects, you can get, the data sets here. If you're jumping ahead and you looked at the project page, right, you're going to have to pick a data set of some interest. This would be kind of a cool one you could play around with, to do some stuff.
I have a question about the data. With the number of people stopped, do they take out the number of people that are already under investigation? Because that seems like it would affect kind of the randomness of it. If they're being investigated, then they're being stopped for a reason, and the chances of them being arrested are likely higher. So I'm kind of wondering that about the data.
I don't know. Did you dig into it, Mauricio, at all? I mean, the answers are probably somewhere on this on this website.
It's a good question, but I would imagine this is it doesn't take into account the phenomenon that you just verbalized.
Yeah. If you dig in, if you look at it, let us know. But I don't know the answer to it. I haven't personally played with this data set, but I've heard of it and I've seen presentations on it. I think it's a super interesting project. The 538 group also has, if you're interested in this kind of thing, they have a data set that they maintain on a couple of data sets, one on mass shootings, which I believe, I can't remember how they define it. I think if it's 3 or more or 4 or more people, or maybe it's 5, I don't know what the threshold is. And also police homicide. So when someone dies in a police interaction, so you can go to 538 and you can find those data sets if you're interested in sort of criminal justice issues and
yeah, that data is for 2015. That one about the police killings.
Yeah, but I think they update it periodically.
Oh, really? I
yeah.
just looked at it and it was only 2000. Maybe there's another one, but yeah, I just did an analysis with it. So
yeah, so
there's some interesting inferences you can make from that thing.
Yeah, for sure.
There's
Yeah,
definitely some.
And 538 makes almost all their data sets publicly available. They're on GitHub, and there's actually a 538R package that is updated, periodically. So if you have a newer article, you can go right to the website. So Alec, I was just making reference, kind of giving ideas for the final project, but I'm not kind of ready to talk about that yet. We'll talk about it in a few weeks. But if you find a data set that you think is interesting, kind of bookmark it and kind of have it in the back of your mind.
I have a question about Mauricio's last answer.
Sure.
Couldn't arrests and car search be thought as numeric? Numeric operations can be performed.
He was
on that.
I think he's if you're thinking about it in terms of raw data, an individual is arrested or not.
Okay.
So in that case, I think it would be dichotomized. But if you're looking at the summary table, and if the record of interest is the county, then it would be numeric. You are correct. So, and actually, I'm going to start going into that a little bit right now. A lot of, so these things can change as you aggregate up and what your unit of analysis is, right? So whether or not you consider the unit of analysis the county, or if you consider it the individual police interaction. So I think he did say up front, he was talking about the raw data, which would be individual encounters. And so that in that case, that would be economized. But if you talk about a county, you're going to average that. So it's going to be that percentage would be continuous. that help, William?
Yeah, great.
And that's another like little nuance that you just got to be careful, and we'll encounter it continuously over the semester. So continue to ask that question as we go through. And yeah, so I'm going to fly through the first section, which is really about data munging, because I don't want to step on Andy's toes and what you're doing in 607, but there's a few little bits I want to just talk about in terms of data munging and then data elements. And I'm not sure if Andy has shown this. This is sort of Hadley's framework for data science, which I find incredibly useful. And I think what's kind of interesting is, the way we structured this program is when you take 607 and 606 together, I envision 607 covering a lot of this import tidy transform. I think a lot of what you're going to do there, and some of that import is going to be web scraping and that kind of, more sophisticated ways of getting data, but you're still importing and you're still shaping it, making it into a tidy format and then transforming it as appropriate. So a lot of the data sets I'll use in this course will be already tidy, and I'll define tidy in just a moment. Tonight, we're going to talk a little bit about transform and much more about visualize, and then the semester is going to be what this modeling, right? A lot of 606 is going to be sort of the visualize, modeling, and of course, communicate. That's kind of what the labs are about. You need to be able to report these out in a reasonable way. So, but I like this framework for thinking about, data analysis or data science, maybe broadly. And I like that this is cyclical, because this is what we're going to do. We're going to get some data. You're going to create some plots, you're going to maybe do some models, then you're going to do some transformations. And, this is kind of keeps going and going until you have a deadline in which you're forced to do some kind of communication. And then you may come back and do more of that. So what do we mean by tidy data? So this kind of goes to your question a little bit, William. So tidy data is a way of representing data where each row represents a particular observation and each column represents some kind of measurement. Okay. And so a lot of the interpretation, so in the case of the policing issue, if we're making inferences about individual, stops, right? So then each row could represent a police interaction or a police stop, right? And so that each measurement is were they arrested or not, right? So that would be dichotomized. But then we could aggregate that and we could have tidy data where each row represents the county, right? So realize now that unit of analysis is different, right? So we're making inferences not about individuals anymore, but about counties, right? And so interpretation could change. But the key is like each row is an observation and each column is a measurement. And that's kind of how we want data. And we're going to eventually get to regression. And that's how we're going to set up our models. We're going to have a whole bunch of measurements across whatever our unit of analysis is. Some are going to be dependent, some are going to be independent variables. And so this is kind of how we want data organized. Now in 607, you're going to find data that's not in tidy, and your goal is to get it to this place. I'm going to presume a lot of the data coming in will already be in this format. So when we talk about data in this class, we're going to talk about two major types. We're going to talk about continuous and discrete. And so the continuous, or, really think about quantitative numerical data. So things like height and weight are, classic continuous variables, but we can have discrete variables as well. As somebody who works in social sciences, for some reason, we always ask salary in bins. Like, do you make between 0 and 15,000, 15,000 and 30,000, right? So that's a discrete variable because it's ordered, right? So there's some natural ordering to it, but the intervals may not be equal. Like Likert response data is a classic discrete variable where there's an order, but the intervals are not equal, right? But that's still, we can still kind of treat that numerical. Or sometimes we can treat it as ordinal, right? Because that's order, and then the categorical things like sex, ethnicity, right? Those are some of our classic things that we got here. Now, of course, we need to map these data types into R. And so I've created this kind of conceptual map to think about. So R has 5 primitive types. So if you came from a programming language, hopefully that makes some sense, but there's like 5 core types of data that you can have in R. Now, all of them are vectors, which is a little bit weird if you come from another programming language, meaning we don't have constants or scalars in R. If you have just the single number or a single string, it is still stored as a vector of length 1, right? So you could then make it have, you can increase its length. So that's a little bit different. Like, so I came from a Java programming language where you have some primitive types like an integer, and then you can create an array of integers. These types are already vectors, right? And I kind of organized them in this hierarchy because then we also have this notion of fidelity, right? And what I mean by fidelity is the kind of accuracy of that information. So we can always go up without losing fidelity. But if we ever want to take data and convert it to formats below, we could potentially lose fidelity. So an example would be if I have a character string. So if I have the word hello, right, I can't convert that to numeric, right? But if I had a number like 20 that was read in as a string, I could do that as an as.numeric, and R will do the right thing. You'll actually get a number. Right. It might be helpful to kind of look at this real quick. So if I go over here, create a new R script, right? So if I have my variable, right, and if I set this equal to, say, 42, right, I can easily do as.integer my var, which is great. But if my var is equal to hello, right, as.integer of my var is going to, I didn't do the assignment, right? I get NA because it doesn't know what to do and even prints a warning for me, right? So going down may be problematic, but I can always go up, right? So I can always start with something like, my var is equal to true, right? Which tells me my var is illogical, right? So I can do as.integer my var. Well, it's going to say, okay, well, it's just going to say 0 is false, 1 is true. I can do as.numeric my var, right, which is fine. And you can't really see it here, unfortunately, in R. So we have to look at the class. We can see now it's numeric. I can even do as.character my var. And I'm not really going to lose fidelity, but notice that it puts the word true in quotes because it's now a character and we can ask, right? So the point being, we can, if we have a logical, we can always represent it as some type above it. But if we have a character, we may not be able to represent it as something below. All right. And so in these primitive vector types, so complex, I kind of, if you're not sure what that is, that's a number that has an imaginary number, right? So if you have basically the square root of -1 is equal to I, which is an imaginary number, something we don't use very often, but you can do it if you're an electrical engineer. It's probably something you're used to, or I used to do a lot of, work in dynamical systems and fractals. So, those are ways of representing numbers. So we'll jump over that. That's here for completeness, but all of these vectors have as dot and is dot functions. So the as dot would convert something to that type. Is dot is going to test to see if that vector is of that type. So you can, if you're doing some coding. A few other things we're going to encounter. Factors technically are integers that have a few attributes attached to it. So internally, R star is a factor as an integer, and it just maintains a mapping such that 1 is equal to white, 2 is equal to Hispanic, et cetera, right? But under the covers, it's still an integer vector. And so there's this extra function here called levels that tells you what that mapping would be. And so there is an as dot factor and an is dot factor, but don't confuse this. This is not a primitive type in R. It's technically a vector. Same thing with date. Date is stored as an integer. It's stored as the number of seconds since January 1st, 1970. And so there is an as dot date. For some reason, there is no is dot date, but I'm going to kind of punt on that. Dates are always kind of problematic. So those are sort of the primitive data types, and we can combine them in a number of ways. So a list is just going to be can contain anything. So you can have lists of lists, you can have lists of data frames, you can have lists of vectors, whatever. So we'll encounter that from time to time through experience. You kind of get a hang of that, but you can think of this as a catch-all. If you need to store something, it can be stored in a list. A data frame, though, is something we're going to be particularly interested in, because what a data frame is that's going to be how we represent this tidy data. So a data frame is essentially a collection of vectors, which are columns, such that the positions of all of those vectors represent a single observation. So it actually becomes a two-dimensional object, but it is in R a collection of vectors. So that's going to be what we're going to be using a lot. So we talk about these data types and our variable types, and the chapter 2 is really about descriptive stats. So I imagine a lot of you have encountered this. So this table, hopefully it provides a little reference and review of the common descriptive stats we're going to use and the common visualizations we want to initially use as we go through, right? So for continuous, so we have mean, median, mode, standard deviation, and interquartile range are going to be our common stats, and we'll use those over and over. Histogram, density, box plots are kind of some other ones. Some things we'll get, so later in the semester, we'll talk about ANOVA, t-test, because I tried to give some examples of, if you have two quantitative variables or two qualitative variables, what are you going to use? So we'll talk about contingency tables tonight, but we'll talk about chi-squared in about 6 weeks or so. I'm hoping all of these terms are largely review. So if you need a review or a question about what they are, ask me, ask Angela, ask on the Slack, or check the textbook. But the one thing I want to point out is, and this is going to come up time and time again throughout the semester, it is this notion of robustness. And in terms of descriptive stats, right, we tend to think of median and interquartile range as being robust statistics. And that's because they are not very influenced by the presence of outliers or skewed distributions. So the classic example I use every semester, but it works, right? So if I took a quick poll of everybody in the class and said, what is your salary, right? And I want to kind of get the center, right? So the one way to do it is just calculate the average. I'm going to sum all of the salaries and divide by 34. There's 34 of us in here, and I'm going to get some number, right? Doesn't matter what it is, but imagine, it's probably, maybe somewhere between 50, 100,000 if you're all employed. I don't know, maybe 30 and not, but probably not, maybe there's a CEO in here. I don't know. Right. But imagine that, right? And I can calculate the median. So for the median, what I'm going to do is going to rank everybody's salary, and I'm going to go between person. Let's see if I can do this off the top of my head, 17 and 18, right? So the median will be the salary between those two people, right? That's the middle. Okay. Now, Bill Gates enrolls in the class, right? So we're going to add his salary to this list. So he's student number 35. So, what's he worth? Billions of dollars. We're going to add that, to that, to that sum, right? So the mean is going to go way high, but the median's going to change very little, right? And so that's what we mean by robustness of these statistics, right? You add this one gigantic outlier, and it's going to have a huge impact on the mean and the standard deviation, it turns out. Well, that was Steve Jobs that had the dollar salary. I'm not sure Bill Gates ever took a dollar salary. Or whatever, right? But so anyways, so that, why is that important? Because a lot of what we're going to learn, at least initially in this semester, relies on these statistics to be robust. And a lot of the things we're learning, regression, the regression models we're going to learn later on, through logistic regression and classification, a lot of classification problems are assuming, are working with means. And so the presence of outliers could have a problem on those inferences. So it seems like a simple slide, but this is really something really important, something you need to keep in mind as you go through, and particularly when you start working with your own data. So to have a little fun here and to demonstrate some of these data visualizations, some of these descriptive stats, we're going to work with Lego sets. And so this is a little package I wrote last year that is interfaces with the Brickset API. So if you want to play around with Lego sets, a good point, Angela, thanks. So if you want to, you can install this from GitHub. And so there's a data set in here called Lego sets, which has 16,355 observations of 35 variables. And here are the variables that are in here. So I'm using the names function that just gives me the column names. So we're going to look at a couple of these variables as we go through. Now, one of the most useful functions that are one of the first functions I use when I'm working with data set, and to me still one of the most useful functions, is the str function. It's short for structure. It's base R, so I don't need to install or load any other packages. And no matter what I give the str function, R usually gives me something somewhat useful, sometimes more useful, like in a data frame. Right, so you can see it tells me, oh, it's a data frame, tells me the number of observations and the number of variables. Then it gives me a list of all the variables that are in this data frame, the variable type. So we can have set ID as an integer. We have the name, which is a character. We can go through. Released is a logical, because the API allows us to get information about sets that haven't been released. So we can look at that. We have number of pieces which is an integer. We have date first available. So we have a date object, right? And then it also, what I really like is it gives me like the first couple of values in the data frame. So I can very quickly at a glance start to get a sense of what's in my data set and my data frame and kind of do it. Now, RStudio has made this a little bit prettier. Essentially, if you're in the environment tab, right? So up here, so here you can see I have the Arbuthnot data set. I can just click expand. And so I can see that the information in this environment tab is coming from the str function. And so RStudio is just going to format this for you. So you don't actually need to call the function and still get the valuable information there. So find that really useful. So we could see here, I just took a random sample of 100 rows just to kind of get so I could look at the data as we go through. All right, so quickly on data wrangling, not going to spend a whole lot doing this, but I'm trying to move to the tidyverse or the dplyr approach to doing data munging. I'm not completely there, but this is a lot of 607, right? How are we going to get that data in there? And this is the one I want to show because I think Andy has 607 is going to be largely in the tidyverse realm. So I'm sorry, I missed your question, Newman. So is median preferred? I actually think you should just report both. But unfortunately, a lot of the statistical tests that we're going to use are designed for means, not medians, unfortunately. So, and particularly ordinary least squares regression and even maximum likelihood estimations are still using means. So there are ways we can deal with that. Yeah, we can reshape data to try to make it more normal. All right, on this sheet, as I said, I've been using R for an extremely long time. So you're going to still find me using this $ notation. And the idea here is you can have a data frame $ variable name. What that does is essentially pulls out a vector from that data frame. So if I need to calculate a mean, I calculate the mean on a vector, not on a data frame. So in order to get that vector, I can use this $. So this is giving examples of some of the basic plotting and descriptive stats using the $. There's this formula notation that's used in the Lattice, but I don't think Lattice is very popular anymore. People are in the tidyverse and ggplot realm. So that's kind of what we're going to focus on a lot, which uses this pipe operator. And so what the pipe operator does is, if you ever use Unix, it's a way of just essentially chaining commands together. The thing I do a lot that got me to use the pipe more recent is I often want to do contingency tables and proportional tables, right? That's my classic descriptive stat for qualitative data. I just want counts, and then I want the proportions of some particular category. So the old base R way to do it is I would call the table function. So you can see I'm using the $ notation. So I'm on the Lego sets, I'm getting the category variable, and I'm calling table, which is going to give me the counts. And then I pass, I have to save that as a variable. And then I pass that to the prop.table. Prop.table takes, table output and calculates the percentages. Or I could do this as this very lovely nested function call, which is maybe a little difficult to parse, where the pipe operator allows me to do that table, and the output of table can be piped into the next function. So you notice here I'm calling prop.table with no parameter. That's because the pipe operator is going to take care of it. So the output of this becomes the input to the first parameter of the next function. And I think this becomes, particularly when you do a lot of manipulations as you go through, I find this a much more legible way of doing it. And you can see here is the output, right? So we could see that 2.8% of the Lego sets are books, but we can scan through now really quickly and see, normal is the most common Lego set, with 71% of the sets being of that category. So filter is the dplyr way of kind of subsetting. So rows. So here we have some data set, and here we're going to have a variable name and some parameters that we want. We have some logical operators, which I summarize on the next one. So the explanation point is the not operator. So if we have, say true, right? I get true. If I do $true, I get false, right? So it's simply the negation of that. If we want to test whether or not two things are equal, we use two equal signs. Not equal is explanation equal signs. We have greater than or equal to, less than or equal to. This one here is kind of cool. The %in% allows us to do kind of a test. So I find this best to show by example. So letters is a built-in vector in R. So if I just type letters, right, I get the alphabet. If I type letters uppercase, I get the alphabet in uppercase. It's kind of useful. But what I want to do is say, is letters in A, E, I, O, and U. I want to find the positions of the vowels. So I can do this. And so essentially what the %in is going to say is letter for each letter, is it A, E, I, O, or U? If it is, true, otherwise false. And so this bit just returns a logical vector, which we could see here, right? And if I could pipe that to the which command, which is then going to give me, which is just going to give me the positions in the vector that are true. So we can see 1, 5, 9, right, 15, 21, etc., are the positions where the vowels are. So this is kind of a handy little function I'll use from time to time, and with a little experience you get to it. The vertical pipe operator is the OR operator. So A or B, if one of them are true, it's true. The ampersand, the ampersand is the AND operator. There is also an is true, but I almost never use that. But just for completeness sake, it's there. All right. So filtering. So I'm going to go through some of these just to show. So here, if I want I'm filtering out data sets that are educational and were released after 2015, right? So I'm taking my Lego sets, calling the filter where theme group is educational and year is greater than 15. And this is how you would do it in base R. I'm not really going to talk about it because if I were you, just learn this way because it's, I think, easier to read and easier to write. But either way, I find out there's 61 Lego sets that fit that criteria. Select is really useful. A lot of times I get data sets that have lots and lots of variables. And so one of the things I'll do is let me just get the variables I'm interested in. It makes it a little bit easier to view. I can view it in a spreadsheet view, what have you. So here, I'm going to take the Lego set and I want set ID, pieces, theme, available, US retail price, and number of minifigs, right? This is how I would do it in the Tidyverse way. And this is how I would do it in the base R. And here I'm looking at the first 4 rows, right? So this becomes a little bit easier to manage. Relocate, if you want to relocate columns, I'm not really going to talk about that. Renaming is kind of nice too. So here you can see I'm calling rename. Instead of US _ retail price, I'm going to call it USD. So you can kind of see, all right, now I have a shorter variable name, or maybe I have a variable name that is a little bit more useful to me. A lot of times I get educational data sets and the variable names are so cryptic. I go to the data dictionary and I'll map them to something that actually is meaningful to me.
Can I ask a question there about
Yes,
this
sure.
previous one?
Yeah.
Something that threw me off here coming from Python was that USD is what's going to be the new name,
Yeah.
the order of it. So is that a tidyverse thing, or is that
Yes.
all?
No, that's a tidyverse because this is the rename is in the dplyr package.
So in R, otherwise, it might be the way I'm more used to.
So in R, right, so I'm calling the names on the data frame, right, which is going to return a character vector. And then I'm changing position 5, column 5 to USD, right? So in base R, you're going to do it more based upon position than sort of old name to new name. But yeah, that's
Okay.
a good question.
Okay, thank you.
Hey, a question about the base R. You said it's based on the position, which would be number 5. Could you use the string name instead?
No, kind of like, so, let's go back to our classic empty cars. So so if I look at empty cars, so if I want to change weight to the full word weight, right? So what I could do is say names empty cars, right? And so I could then say names empty cars equals weight, right? So recognize what is this piece, right, is giving me a logical vector, and it's true in only the position where it's weight, right? And so if I call this, so I'm subsetting names empty cars where it's weight. So now I can do weight, right? And now if I look at the head of empty cars, I now have renamed that as weight. I know I did that super fast. So, so to answer your question, yes, but I don't find this very pleasant.
Excuse me.
Yeah.
Yeah, I was gonna ask, what if you say weight and then you assign equals that? Is that gonna work, or you have to put that in the parentheses? I mean, you have to put the weight on the right hand side.
Yeah, you got to
know
put
what
it
I
on the
mean?
right hand side because you're just redoing that attribute. So let me I think if I do that, I'm gonna get the old data set back. Oh shoot, I keep hitting save. So what you're suggesting, I don't think this will work. So if I say empty cars, can I just say weight like that? I don't think that, yeah, that doesn't work.
No, that's not
Because
what
it's not a
I mean.
named vector.
That's what I mean is like weight, when you spell it out,
Mhm.
you put it first and then you assign it to all of that. Like just reverse the position. Wouldn't that work? Like assigning a new, that doesn't work?
No, because I need to, I'm trying to assign just the weight. If I took this part out, then I would just reassign, well, it gets weight on the first one and then NA to the rest, because I'm trying to assign a whole bunch to, this is returning, I don't know how long this is, 11, a vector of 11. So, I could do a character vector of a length 11 and it'll just assign each column. I'm sorry, I'm having a hard time understanding your question,
Okay.
but continue.
Yeah, it's all right. It's all right. I'll just figure it out.
One of the tricky things about R is that there are so many ways to do things, which makes learning it sometimes a little bit difficult, admittedly. So I hope these slides are reference. I encourage you to just learn the dplyr way, but just be exposed to the base R, because there's still a lot of folks who, myself included, will still use the base R stuff approach.
I'll just go with dplyr.
Yeah, that's my recommendation at this point. Okay, rename, we talked about rename, mutate. I'm going to punt on mutate because we'll see that a little bit. And okay, well, there's group by and summarize. I will happily talk about these next week, but I think Andy's going to cover this. So that's kind of why I'm okay just skipping over. And if he doesn't, tell me and I'm happy to talk about it. The one function I'm not sure he's going to do, and it's a function, maybe it's just the way I learned R, because I learned R before there was, so before Tidyverse, there was Hadleyverse. And before that, there were other things. So one of the most useful functions I still use quite a lot is the describe function. So there's a really handy package called Psych. Lots of useful functions in here. It's really designed for psychometricians and, psychology and social sciences. So there's things in there for liability measures and the like, but there's these describe and describe by functions. So here, and they're really meant for quantitative variables, but you'll see, you can kind of do quantitative with qualitative. So if I just call describe, here I'm using US retail price. The reason why I like this is it gives me almost all of the descriptive stats I would want in one command. I have N, I have mean, a standard deviation, median, trimmed mean, which is kind of neat, which is useful as a way of comparing it to mean in terms of determining whether or not there's outliers, because what it does is it drops the lowest 10%, the highest 10%, and then recalculates the mean using only the middle 80% of values. So if you have outliers, right, the trim mean might be very different than the regular mean. And so in this case, it is, right? You're looking at $8, over $8 difference between the median. So gives me an initial cue. We're going to look at some plots in a minute that there's some skewness going on. Min, max, there's some skewness measures that I'm not going to really, standard error we'll talk about exhaustively the rest of the semester. But so lots of really kind of useful statistics. And then here I can add a group variable. So on availability, so now I could get all these descriptives separate for each kind of category that I might be interested in, right? So this to me is a super powerful function. I often save this, right, because this is a data frame. So now I can use this as an input to ggplot or a table I'm going to put in a report, right? And I might tweak it and do some stuff before I do that. But I find these really, really useful. So wow, we're at 9:27. I know everyone asked, are we going to go an hour and a half? I'm going to fly through this and then I'll stay on and answer clarifying questions. My hope is that these plot types aren't new to you guys. And so really what I just want to show is the basic framework for how to do things in ggplot. And this is just going to take experience, right? The labs have largely all been converted to do ggplot when necessary. Just in short, right? So ggplot was written by Hadley Wickham. And it's based upon Wilkinson's work. So he wrote a book in 2005 called Grammar of Graphics, which really just describes a framework for doing data visualizations, which is kind of this layered approach to creating visualizations. Now realize in the late 90s, early 2000s, I worked for a GIS company doing lots of mapping. And so this layered based approach was completely natural. If you've ever done mapping stuff, you kind of build maps that way. You do, you have polygon layers, line layers, and points. You kind of build these things up. So ggplot kind of works in a similar fashion. And the idea is, to allow you to create fairly complex plots with a fairly simple syntax. There's a couple of different ways we can, work with ggplot. Really going to focus in on this number 2, where we have the ggplot, and we're going to layer on geoms. So there are kind of a couple of basic components. So every ggplot starts with a call to the ggplot function. And the first parameter is always going to be your data frame. Like what is the data that you're going to build this plot against or with? And then you define the aesthetics. Okay, and the aesthetics are defining the components of the plot. So X and Y are typically going to be there. Now, sometimes you might only have X and not Y in the case of histograms and bar plots, right? That's a one-dimensional thing and it'll do some binning for you. But typically X and Y are going to be there. But you can have color, you can have size, you can have shape, you can have line type, right? And so the aesthetic is the piece that's mapping the elements, like the X and the Y, to variables in the data frame. Okay, and so that's kind of the key. That's where you start. How is my data? What are the columns in my data that should be mapped to elements of the plot? And then I'm just going to add layers, right? And so you can have points, you can have histograms. There's a lot. This is at minimum what you need. You just need these two pieces to build a ggplot. The rest are kind of optional, like, but can be quite powerful. The facets are a way of creating sort of separate plots based upon some other variable. And we'll look at examples to probably make it a little bit clearer. You can do scaling directly in ggplot. So you have a skewed distribution, you want to do a log transformation, you can do that. And then there's sort of other options to make your plot pretty, such as like setting a title, changing the limits on the X and Y axis, changing labels, et cetera, et cetera. So here's, as of when I built the slide deck earlier, these are all the geoms that are currently built into the ggplot2 package. So there's a lot of things you can choose from. We're probably going to use about a half dozen or so of these fairly regularly throughout the class. Of course, there's a cheat sheet. So here you get a little visualization. So I'd recommend, this is a link in the slide deck. So when it's posted, you can click it and get the PDF, or you can just go, I think I had a link somewhere else on the website. Really useful, nice to have available. So the most basic, right? So a scatter plot. So here we're plotting number of pieces against US retail price on the Y-axis. So we can see there's a bit of a relationship. We can also see there's probably a bit of skewed distributions in both pieces and US retail prices. And so we start here, which might seem like a lot because in base R, I can create this plot in a lot fewer characters. But now I can do things like, well, let's add in another dimension. So I'm going to change the color of the points based upon the availability of that point. And all I have to do is add color, right? So there's a color aesthetic, and availability is the name of the variable on that Lego data sets. I can go a step further. There's a size aesthetic. So the size of the points are now proportional to the number of minifigs in that set, right? And so I got a little legend over here on the right-hand side. So now I'm representing 4 different variables in a single plot, which can be kind of useful. Now, maybe I want to split that out instead of coloring on availability, because basically if you have more than 4 or 5 categories, for me, it's kind of hard to see the colors. So it might be better to say, well, let's create essentially a separate scatter plot. So here I just move this over as facet wrap, and I'm faceting on availability. So I can quickly see not sold, unknown, Legoland exclusive, educational rates. So there's not a whole lot of data points. So Lego exclusive is large, retail limited, right? So that's where most of the data is. We can do box plots. A single box plot is not often useful. And in fact, I had to create a dummy X variable here to make it work. But like this kind of box plot is very useful, and we'll use this a lot throughout the semester. So here I have availability, and so I can get a sense of the distribution of retail price across all of those different categories rather quickly. I usually like to, and this is a case where I'm trying to show a decoration, I can flip it. I tend to like my box plots horizontally because I find them a little easier to read, but that's just me. But I see lots of skewness here, and this will be a useful tool when we start talking about null hypothesis testing and the various things. We could do histograms so we can see that US retail price is indeed skewed. We have one set here that's $800. Any Lego fans here? Anyone know what set that is?
The Death Star.
No, it's the Millennium Falcon. Yeah, the Ultimate Collector's Edition. Yeah, it's large. All right, so here's histogram. So I took retail price, and all I did is I wanted to show the scaling. So here's a case where I did a log transformation. Now I have a much more normal looking distribution. Looks almost like it could be tri or bimodal. Only thing I'll say tonight on histograms is be careful on bin width. There's a parameter. In fact, I think that this command will throw a warning in ggplot and says, you probably should pick a better bin width. Basically don't let us guess, because it's often not good, but bin width could be, something you play around with to look at that. Or, okay, there's availability. I usually use density plots, which is kind of a smooth histogram. Again, we see a lot of skewness here. We have different colors. All right, another little cheat sheet for you to have.
I have a question.
Yeah, please.
Yes. Does the number of bins affect the interpretation of your histogram?
Number of bins, say that again.
Yeah, I mean, does the number of beings affect the interpretation of
Oh,
your?
for sure. Oh, yeah, yeah. Oh, yeah. Without question. Yep. I don't know how quickly I can, let's see if I take this command, let me go over here. Do I have, I need to say library brick link. I think, let me put that in. What was the name of the package?
Brickset.
Brickset, thank you. I only wrote the package and I can't even remember it. All right, and then I need to do data Lego sets. All right, so let's take a look. So here, you can see here's the warning, right? It's using bins equals 40. So, or 30, I'm sorry, bins equals 30, right? So we get that. What if we do 10, right? Much wider bins, right? You want to go extreme, let's do 4, right? Does that change your interpretation? What if I do, let's go to 50, right? If this is kind of an interesting one. So, you know, a lot of times what we're interested in doing is determining whether or not this is a normal distribution. Of course, now we're looking at log retail price, not retail price. But you might know this, with this many bins, we see these gaps, right? And that's because it's unlikely that we have a Lego set that's $50. It's probably $49.99, right? That kind of mental trick, which is going to have an impact. So we might not have any sets between 50 and 55, because then the next set is going to be priced at like $59.99, right there, or the sets tend to be in $5 or $10 increments. So if you get the bins, too many bins, well, there's no sets that fall within that price bin, right? Which is why you got that. So the answer, you know, a long-winded question, the answer to your question, yes, absolutely. Bins do that, which is why I like the, instead of geom histogram, if you do geom density, right? You can think of this as a smooth density, right? So here we can see, well, actually there is a little bit of gaps here. Can't really tell on the log scale where that is, but now we get kind of a more smooth way to do it. Oh, so how do we select the optimum bid number for correct interpretations? Angela, do you have any good rules of thumb? I don't know if I know any. It's sort of a little bit of an art.
I was going to say it depends on the context, right? So like for the example that you gave with the Lego prices, you know that the $29.99, $49.99 would make a difference in how the histogram is showing. And so, I mean, we can think about grades.
Yeah.
Right. And so using grades as an example, we would probably, bins of 20 might be okay. Bins of 50 might be too many. So it's important to think in context what it is, and then play around with it to see what makes the most sense.
I was actually just working, this actually just came up earlier. So we were involved in another project. I had a meeting this afternoon where we're looking at survey respondents, and we have a suspicion that there are some people cheating. And so we're trying to figure out ways of detecting it. And so one thing I started to do is started creating histograms based upon survey completion time. And sort of setting the bin width became important. So I started with like each bin is a day. And I kind of saw, oh, well, clearly there are some days where there are a lot more respondents. But then I went to, let's do bin widths that are equal to 1 hour. And that's where we started to find interesting things. We saw, whoa, there's a few spikes, just a couple. We go look at those times and we found, oh, somebody submitted, it looks like there were 12 survey responses at exactly the same minute.
Oh, wow.
Literally the exact same minute, right? Which is kind of crazy. It could be a coincidence, but probably not, right? So, but that let us down. So the bin width is how we detected that. It was like, when we looked at it over a day, it kind of smoothed out, but we had these kind of spikes. And so, yeah, I mean, that's today that happened. The bin width made a huge difference in seeing that and being able to detect. So once we had that, we were like, okay, let's look at all the responses within that time frame. And then we looked at the completion dates and they were all the same. Cool. All right. Aesthetic. Okay. So there's a lot to take on here in ggplot. I understand. And so I'm going to be using these over and over. So I'm trying to introduce these as a reference point right now. Right. So you see something you don't know. So this is another one I think is kind of useful. I think, and Angela seemed to like it earlier when I showed it to you.
Yeah.
So these on the here we have all of the different geometry types you can use, and there's only like histogram, the point, bar, geom bar, geom density. I should create a slide with like the 5 or 6 that we're going to use the most, and those are the ones you're going to focus on. Or you're going to work on the lab on this one, so you're going to encounter just a few. There are a lot, but don't worry about it. But this chart, what I like about it is, let's go to here's the geom box plot, right? And so then these are all of the aesthetics that are available in ggplot, but not all aesthetics are available for all geometry types, right? So for a box plot, X end and Y end don't make sense. Shape doesn't make sense because it's a box, right? You can't change the shape. But for points, right, shape could be important, right? So the way this works is the colors, right? So if you do nothing else, if you have a shape for that row with the aesthetic, you know that that aesthetic is something you could set, right? And that might be a good start. But the yellow squares, the key is at the bottom, right, are aesthetics that you're going to generally set within the AES function call, right? Meaning the aesthetic is going to be set by a data variable in your data frame. Okay. Now, if it's a green triangle, and there's not too many of them, width is one, I guess on histograms, you have color and line type stuff. Those are generally set outside the aesthetic component, meaning it's going to be the same for all those geometries on the plot. Okay. And then the blue circles are ones that are usually in the aesthetic call, but don't have to be. Meaning, if we look at the box plot, no, let's go to point, because that might be a little bit, right? So we have X and Y are usually in the aesthetic, but you can put it outside the aesthetic to draw one point on the plot, right? And it's just fixed, and then you don't have a data set, right? So that's a little bit confusing, but it's usually there, but it doesn't have to be. The green ones has to be outside. The yellow squares has to be on the inside, right? So that's kind of how you interpret this. But for now, I think what would be useful is, what can I set for a box plot? What can I set for a point? And this little chart might help you do that. All right. Well, I skipped back. All right. I'm going to skip Likert plots, and given the time, because it's not terribly pertinent, I'll talk about dual scales next week. But I would feel remiss. Let me do my Angela's sighing. So if you're going through the textbook, you will find exactly one pie chart, I think, in the textbook. And so here's let me just real quick to yourself. Here are 3 pie charts. Can you tell me what the difference of these 3 pie charts are? Is there a difference first? And if there is, what is it?
Tell.
Anybody want to take a stab?
Individual proportions are different, no? I mean, the red on the C and A are different. I imagine everything else is.
Yeah. Is it a little easier to see it this way? So this is from Wikipedia. And so there's a famous statistician of the last century, one of the more important statisticians of the last century. I absolutely love and agree with this chart, or this quote. It says, there is no data that can be displayed in a pie chart that cannot be better displayed in some other type of chart. Edward Tufte, who is another sort of dominant figure in data visualization, written numerous books. If you have an opportunity to see him speak, I highly recommend it. Extremely smart guy. He talks about pie charts in terms of chart junk, and he talks about like the ink to information ratio, and pie charts are really bad. Turns out that there is also a very large literature on human perception, and humans actually have a really difficult time interpreting area in particular, right? Comparing different areas. And in pie charts, not only you're trying to compare area, you're trying to compare areas that have arc angles, which we as human beings have a very difficult time, right? So all this to say, I have very, very few absolutes in my life, right? I am in a field that is concerned with measuring uncertainty of things, right? And there's always kind of levels of confidence. But here's an absolute: just don't use pie charts. There is never, ever an instance to use a pie chart. If you use pie charts for your project, you will lose points. So just be clear on that. So there, and I used to give a challenge, but I would get silly things. Like I've seen the pie chart of the pyramid. I've seen the Pac-Man pie chart. They're all very cute. I like them, but they're not just, not designed to display data. Like there is always a better way to display data than a pie chart. So that's my kind of only thing I'll be really a stickler about in this course and going forward. If I happen to watch your, I've sat in on some capstone projects, please don't use a pie chart in your capstone either, because our theory is a little less absolute. We have fun over this one, but he still hasn't come up with a better chart. All right, so I got a bunch of other resources. Let me get this link in here. So I promise we'll talk about the dual scales, because that's a situation where I kind of used to be a little bit more absolutist about it, but my thinking has changed. But it revolves around something that we're going to talk about in a couple of weeks. So maybe I'll move it to that slide deck. But here's some great resources for data wrangling. Some of these I think you probably have already encountered, particularly because I think they're on Andy's syllabus. For data visualization, all of these things are freely available. Hadley is, and RStudio is so fantastic. All of the books they publish, you can get them, whether they're Springer or Chapman Hill. They generally make a version freely available on the web, using Creative Commons licensing. So, use those resources. They're there. Have them bookmarked so you can get to them. So there's lots of great stuff here. So I have links there for you. Oops, didn't mean to click that. All right, so I put the 1 minute paper in there. I am sorry we went so far over again. I really try to rein this in, but I think there's a lot of content here, and I'm happy to stay on and answer questions if people have it, but that's kind of what I got prepared. So Ray's asking, where do you find the chart with the ggplot types we can use? Well, it's going to be the picture in the slide deck is linked. So if you click this, but I'll put the link. Oh, bummer. Just wait for I post it, because it looks like it's linking to my local file. It'll be up on GitHub soon. Click the forms link, and that will take you to a Google form. I just put something else in my clipboard, so I lost it. Hold on. This. All right, so if you click that link, you should go in. Make sure, please, because this is how we do the summary, and we can filter things out. So under topic, you're now going to pick summarizing data, chapter 2. Okay, how does one write in our library? Very carefully. So I usually just start with a package I already wrote, paste it in a new directory and start changing it. There is a package called Use This, which has become
from scratch. I mean,
yeah. So there's a package called Use This. And I think one of the functions in here, is this the one I want? Yeah, this is Jenny. Okay, here we go. Reference, maybe. No, articles. I thought it was in here. Oh, here it is. there's a create package. So you can call this function and it will create the skeleton of a package. And so that was that. I'll look at that later. So probably one thing you could do is if I go to GitHub, GitHub, JBriar, and just let's look at data 606. So I have an R package for the course. You can kind of get a sense. So a package is really just the standardized structure of files within a folder. So you start with like this description, which is, I can't remember what format this is, but it's like, have parameters and values. So you can see this is the package name. It's a type is always package, title, version, right? Stuff like that. So that this will create that. There's a namespace that I won't go into much, but you should use Roxygen too if you're going to write packages. And so really the functions end up in just R scripts in the R folder. And so you can see here's the start lab function that you guys are using, right? And so it's writing a function. And the way I do my packages is I use this special kind of comments called Roxygen, which are pound explanation, right? So if you're interested, I would recommend doing that. There's a number of really good, I think Hadley actually wrote the book on packages. Let me see. So Wick and
Can we do it as a project for your course?
It's a little bit above and beyond for my course, but it could be a capstone for sure. I think that would be a great capstone course. Yeah. So this is probably where you want to begin. Actually, I'll put the link in the chat. So Hadley and Jenny are fantastic teachers, good writers. So this would give you the introduction. So, but I mean, if you want, you could do your project within a package, but I would think about it as a capstone. I think that would be a phenomenal capstone project. But the key is think of like a concise set of functionality that you want to implement. Yeah. And then I can even show you how to make the little like hex, stickers, which is what, let's see here. Okay, so David's asking, how do I get change the labels of the axis of, so it's X lab and Y lab. And the main lab is GG title. And there's actually two parameters to GG title. There's title and subtitle. So you can add a subtitle if you want. Good questions. Noah says, I Googled this and got too technical in the answer. So I'm looking for a simple answer. What is the point of mapping parameter? Oh, that's a good question. So if we look at, I hope you guys discovered this, but if you put question mark in front of any function in R, it will give you the documentation. So I think technically, it takes me to the main one. I want the ggplot function, which I could dig to. Here's a cool function, formals. Oh, did I? No, I must have. Oh, it's not ggplot2. I apologize. It's just ggplot. Yep. ggplot2 is the package. Yeah, look at that. So the parameter. Okay, so how do I say this? So R is funny. If you know another programming language, does Python do this? I don't know Python well enough, but you can pass parameters either named or by position. So because you always start with the data frame and the aesthetic comes second, you don't actually have to specify mapping, but technically the aesthetic is the value of the mapping parameter. And data is the variable name. So going back to, that's a good question. So I can take this, right? So we get this thing, but if I want to be complete, I could say data equals, and I could say mapping equals, right? I'm going to get the same answer, but so the aesthetic is the value for the mapping parameter in the documentation, which you can see right here.
Yeah, Python does that too, but it's just never mentioned anywhere. So, okay.
Good question. That's yeah. Good night for those who are dropping off. Which ones are required and which ones are optional? So typically, well, sometimes you don't know. I think that's, sometimes you got to actually read the documentation, and not all the documentation is good. So sometimes it's going to be trial and error. But in general, so you can see here, this is the sort of the definition for the function. So, and if I do ggplot, like, oops, like this, I'll get the source code. Don't ask me what use method is. It's kind of R's, object-oriented programming. So you could see here where, so this is the sort of functional definition. And so in general, right, this is an absolute. If the variable has been assigned a value, right? So null is going to be the default value for data, and an empty AES is the default for mapping. This is kind of a bad one, but let's look at mean, right? Which has X, but X isn't equal to something by default, right? Which means it's probably required, right? So that equal means if I don't specify data, it's equal to null by default. So let me think here. Can I, so if I look at the describe, oh, I didn't load the site package. What's describe look like? Oh, I don't know why it keeps doing that. Okay, this is a long function. Okay, right. So looking at describe, X is not equal to anything. So that tells me it's probably required. The rest are optional because they're set to some value. If I don't change it, na.rm is going to be true. Intercept is going to be false. Skewness is going to be true, et cetera, et cetera. So that's one way to tell, but again, that may not always be the case. Okay, did I get all the Google? Okay, technical answer. Right, folks, I'm logging off. Yep. Which are correct? Which ones are optional for me? Yeah, okay, answer that. Currently logged into the class feedback form with my Gmails. That's okay. That's fine. Just because you're going to use your name, that's what we'll use to match it up. Just be consistent. That's all. If you use your Gmail every week. Oh, Angela said that. Sorry. All right. Are we good? Thanks for sticking around, those who stuck around. We'll try to rein this into closer to an hour. But have a good night, everyone.
Thank you.
Professor, I have a question.
Yeah, sure.
I received an email saying that my DAX form has not been completed.
Yeah, you can ignore that for now. We're working on it. I don't know why Blackboard.
I think my situation is different.
Oh.
Because I took the class in the spring. I had done it already. So when I tried to do it, see that it's already filled out. So let me do it again.
So here, let me show you. So if you go into my.dax and you log in, oh, I'm logged in this. So let's log in here. This is my student count. Uh-oh. Oh. No. Right here, when you're in the self-regulate learning results, there's a retake button.
Oh, just retake it? Okay.
Yeah, you can take it as many. You can see I took it a lot of times.
All right, I'll do that. Thank you.
Yeah, no problem. Let's see here. Week 2 isn't even due till Sunday. Angela said she started grading week 1.
Week 1, yeah. So we'll work on that next week. Grading homework number 2. But is there a particular question that you have about it?
No, Angela. Just want to see feedback because we answered what went wrong and what went right.
Gotcha.
So the week 1 needs for the DAX, we'll see the grading.
Yes, some of it's in there already. You just probably just didn't get to your assignment yet.
Okay,
Right, yeah.
okay. Thank you.
Yep. Oh, so cute.
It is my son who is singing. I have a 14-year-old son. Sorry
Hi,
about
son.
him.
No, don't be sorry. Don't be sorry. Yeah. All right. Anything else? All right, Angela, I'll see you Monday, I guess. But we'll
Yep.
talk.
Yep, sounds good.
Have a good one.
You too. Take care. Good night, everyone.